Hello everyone, I'm Teacher Feng. Are you ready to learn science with me? That's great. Previously, you have learned about the law of reflection and image formation by mirrors. This time, we will identify ways in which the properties of mirrors and lenses determine their use in optical instruments. What are the properties of mirrors and lenses? Lens and mirrors have several applications in our day-to-day life. People often confuse these two devices as they look similar, but in reality, they are entirely different from each other in terms of purpose and usefulness.
Mirror is a piece of glass that is polished from the outer surface or back. It reflects light that falls on its surface. It is made by polishing the outer surface of a glass. It has only one focal point as it has only one reflecting surface. Whereas lens is a clear object that refracts light to make images that can be virtual or real.
There are three types of mirror. The first one is plane mirror. It is a flat mirror that reflects light rays in the same order as they fall on the mirror. In other words, the light is reflected at the same angle as the angle of incidence. The image in a plane mirror is reversed from left to right without top-bottom vertical reversal. The size and distance of the object are same in a plane mirror reflection as it is in reality and form virtual image. Next we have concave mirror. It does not have a flat reflective surface. Its reflective surface curves inward and resembles the interior of a bowl. It is thicker at the edges than the center and produces upright, larger images, either real or virtual. The third one is convex mirror. It also does not have a flat reflective surface. Its reflective surface bends out or curves outward like the outer surface of a bowl. It is thicker in the middle than at the edges. The images of an object produced by convex mirror are upright and smaller than the objects look in reality. Also, the type of image formed in this mirror is virtual. Now let's move on to the two types of lenses. The first one is a concave lens or diverging lens. It is thicker on the edges than its middle portion, and thus the rays which pass through the concave lens are diverted away from the focal point and only virtual and smaller images are produced. It is usually used in TV projectors. The second one is a convex lens or converging lens. It is thicker in the middle than the outside edges, and its surface is curved outward from the center. It converges light that travels through it into a single point. In other words, the parallel rays of light join at the same point after passing through the convex lens. The image produced by the convex lens depends on the distance and position of the object being viewed. It is used in binoculars, telescope, magnifier, and others.
So what are the uses of mirrors and lenses in optical instrument? The following informations describe some properties of mirrors and lenses. It also explains how light is reflect and create images and why they have created such images. Let us find out how these properties of lenses and mirrors are being used in common optical instrument. First, we have security mirror and side mirror. Convex mirrors are used for security purposes in stores because they broaden the reflected field of vision. The images are smaller than the objects, but the mirrors help to see a wide area. Next, we have a periscope. It is an optical instrument that allows objects that are not in direct line of sight to be viewed. A simple periscope only requires mirrors, whereas a more complicated periscope utilizes prisms rather than mirrors. A periscope works on the law of reflection, which states that the light from the object falls on one mirror at a 45 degrees angle from the object and is reflected. This reflected light then falls on another mirror and is again reflected until it reaches the human eye. Next, we have kaleidoscope. It is an optical instrument consisting of two or more reflecting surfaces. The basic principles used are the law of reflection, and white light is a combination of all the colors. When white light hits the surface of the mirror, it gets reflected at an angle such that the angle of incidence is equal to the angle of reflection. Due to these multiple reflections of light, there is a creation of these beautiful patterns as shown below. According to the second principle, white light passes through the colored objects present in the kaleidoscope so that most of the light is absorbed by these objects. Next is flashlights. Concave mirrors are also used in flashlights. The use of concave mirror in a flashlight is to parallel the light so that all light can move straight ahead. If you open the glass front cover of the flashlight and release the concave mirror, the resulting flashlight will widen in all directions and cannot illuminate objects or road surfaces at a distance. Next is a magnifying glass, also called as a hand lens in laboratory context. It is a single thin biconvex lens that produces a magnified image of an object. It produces a virtual image that is magnified and upright. All light rays travel in a single point. Then we have glasses. Opticians use concave lenses to correct nearsightedness, also called myopia. A nearsighted eyeball is too long and the image of a faraway object falls short of the retina. Concave lenses in glasses correct this shortfall by spreading out the light before it reaches the eye, thereby enabling the person using them to see distant objects more clearly. Next, we have microscopes. These utilize convex lenses to create extremely magnified images of small objects. Most simple microscopes consist of three lenses. The first lens at the end of the microscope produces a magnified and inverted image. The second lens inverts and magnifies this image, while the final lens, which is the eyepiece, delivers the magnified upright image of the object viewed in front of the first lens. By changing the distance of the first lens from the object, the image delivered to the eyepiece will appear more or less magnified. Then we have cameras. Utilize converging lenses not only to focus an image but also to magnify it. Most camera lenses consist of a converging lens, followed by a diverging lens, then by a second converging lens. The first lens controls the magnification level of the image by moving toward or away from the object. Light passes through the first lens and through the diverging lens, which flips the inverted image. The final converging lens then inverts the image one last time and delivers the image to the rear of the camera. Lastly, the image then prints on the film or on digital media surface. Next, we have telescopes. These employ convex lenses to magnify objects and make them appear closer. But convex lenses do not transfer light accurately. They create distortions and blurs. A refractor telescope uses a large lens to gather light, whereas a reflector telescope uses a large mirror to gather light. Each telescope has its own advantage. For instance, the refractor is better for observing the planets and the moon, while the reflector for deep sky objects such as galaxies. A reflector telescope, on the other hand, uses concave mirrors. Light ray travels down the tube where it is reflected, hence the name reflector, up to a secondary mirror near the top of the tube, which directs the light into the eyepiece. Whereas a refractor telescope uses convex lenses to collect, focus, and magnify light. Rays of light travel through the objective lens where they are focused at the focal length of the eyepiece. Lastly, we have binoculars, which are simply two telescopes side by side, one for each eye. The magnifying glass nearest the object is called the objective lens. The one nearest your eye, the eyepiece. The objective lens and the eyepiece are two elements in all binoculars. To make the image right side up, binoculars need a third element, the erecting prisms. Light rays that have entered the prism cannot get out if they strike a surface at too great an angle. Instead, they reflect back as if from a perfect. Now let us summarize what we have learned for today. Mirror implies a glass surface with a silvery backing that produces image through reflection. It can be plain or curved. Lens is a transparent substance of glass or plastic bound by two surfaces, whose at least one surface is curved. It is usually curved with one or both sides. It uses the working principle of refraction. Optical instruments are based on optics. They use mirrors and lenses to reflect and refract light and form images. Optical instruments and flat surface that use mirror include periscope, kaleidoscope, flashlights, security mirror, and side mirror. Lenses are used in the following optical instruments: eyeglasses, flashlights, magnifying glass, binoculars, telescopes, and cameras. Now, let us check your understanding. Number 1. Which of the following is a concave mirror? Is it letter A, letter B, letter C, or letter D? Number 2. Which of the following can be used to form a real image? A. Concave mirror only, B. Plane mirror only, C. Convex mirror only, or D. Both concave and convex mirrors? Number 3. Light rays that enter the eye are refracted by the lens and cornea so that they focus on the back of the eye. If they do not focus on the back of the eye, a blurry image will result. When this occurs, glasses or contact lenses may be used to correct the vision, causing the light to focus on the back of the eye. The vision may be corrected by using A. Concave lens to spread the light entering the eye, B. Concave lens to meet the light entering the eye, C. Convex lens to spread the light entering the eye, or D. Convex lens to meet the light entering the eye. Number 4. A flashlight and the lights in a car use a blank mirror to create the beam of light. A. Convex, B. Parabolic, C. Concave, D. Plane. Number 5. Which of the following is incorrect? A. A concave mirror can give a magnified virtual image. B. A concave mirror can give a magnified real image. C. A virtual image given by a concave mirror is inverted. D. The real image given by a concave mirror is inverted. And that concludes our topic for today. Thank you so much for joining me today. I hope you guys have learned something out from our discussion. See you!